the three files that I just downloaded from the eClass. Okay, we have the IPYNV, it means the file for the Jupyter Notebook, and then there is one CSV file that I'm going to use for the examples. So let's say I'm going to make a new folder. So I make a new folder here. Oh. Let me make a new folder. So let's say I make the DMB 2022. Where's let me make a new folder here. Okay, let me just make another folder named notebook DMB. So in this folder, I would like to place the three files, the Python solution for the assignment, and then the housing and the Python machine learning basic. And for the first, I hope that you already installed the Anaconda. If you are not using the Anaconda, maybe you can use another tool like Visual Studio Code, or there's also some other tools like PyCharm. Yeah, it's up to you what kind of tools you want to use for the Python, but I will use this IPYNV. So in my computer, I already have the Anaconda Navigator. So you can download the Anaconda. As I mentioned to you, if you install this one earlier, it will be very helpful for you. So if you go to the internet, you can download the Anaconda. The Anaconda here is the Anaconda for the data science. So this Anaconda, you can download it for free, and they have the Windows version, Mac version, and the Linux version. So it depends on your computer. You can download the installer. And after you download this one, you can run the Anaconda, and the Anaconda Navigator shown like this one. So in this Anaconda Navigator, there are many tools that you can use for doing the data analysis. Yeah, you can use the data spell, or you can use the Datalog, IBM Watson, JupyterLab, Jupyter Notebook, and also Orange is available here. But we're not going to use Orange here, but I'm going to use the JupyterLab or Jupyter Notebook. So let me just use the JupyterLab in this class, and you can click Launch here. So I hope that you already have this one. And you can arrange what folder that you want to use. So in this case, I'm already making a new folder, which is notebook DMB. So if you go to this folder, notebook DMB, then you can see the files that you downloaded from the materials in the class. So you can just double click on this Python solution for assignment. If you still remember the assignment one in this class, okay. So that time we used two kind of data, churn modeling and customer data. So let me just download again the data, the assignment. Here, let me download the data. See this. This is the problem. And okay, I will copy the files. The files is there are two files, churn modeling 01 and customer data. So I will just get those data and put it into the notebook TMP. So here I have the, so in the folder that I'm going to use is, now we have 5 files. Okay, Python solution for the assignment, and then Python ML basic. Yeah, I would like to explain later. And we have the housing.csv. This is the data set that I'm going to explain later. And there are two additional files. They are the data that you use for your assignment. I cannot give you the details of Python for all syntax, but let me just give you how we can solve our assignment with Python. So first, in any of the data science environment, we need to use the library. There are two basic libraries in the data science or the data mining. The first is Pandas, Python for data analysis. We call it Pandas. And the other is the NumPy. NumPy is the numerical Python. So whenever you use any numerical data, yeah, it is very good to use NumPy because they provide many functions. And for this data analysis, yeah, it is also good to use Pandas because in Pandas they also have many functions like to read the data and to do some analysis. So when we want to check our data, then you need to read. So here we want to read the CSV file. What is the CSV file? We have two CSV files. The first is the churn modeling, and the second is the customer data. So I would like to put the churn, the variable churn. It means this is the variable for the churn modeling 01.csv. And I'm using the function read CSV. The second one is the customer. It is to check the customer data. So I'm using the read CSV as well because those two data are in the CSV form. So you can run this. Oh, I need to run this one first. And to run this one first, and then I can run the read CSV file. After you read the CSV file, then you can check the data. That means I want to see the first 5 data. The first 5 data, it means the first 5 rows. And you can see this one, the row number, customer ID, credit score, geography, tenure, balance, number of products, as credit card, is active member, estimated salary, and absolute. So those data are the data that you use for your assignment. And we are also looking at the customer dot head. So again, we want to see the first 5 rows. Actually, you can change this head. Let's say I want to check 10 data. So you can specify with number 10. Then you will see there are the first 10 data. So we have the customer identification, and then the surname, age, gender, and etc. In the assignment problem, the first is to read the data. And next is we are going to merge the two data sets based on the customer identification. How can we do this one? In Orange, it is very simple. You can just drag and drop the widget, and then you can check what is the attribute for the combination or for the merging. But in Python, you need to specify. So I give you the function merge, and we need to specify what is the variable or what is the data that you want to merge, what is the data that you want to combine. In this case, the churn and the customer. Churn is the first data set, which is the churn modeling one, and the customer is the second data set, which is the customer data. So I would like to combine the churn and the customer left on. Left on means I want to check the table on the left, and let's use the attribute customer ID. And then I would like to check the table on the right, and the attribute is customer identification. So the left on refers to the churn, and the right on refers to the customer. So I would like to combine those two, whether the left they use the customer ID, and on the right they use the customer identification. If you look at the data, the customer ID is on this churn modeling, and the customer identification is in the customer data. So we need to specify the column name. So after you do the merging, let's see again the data, whether they are really merging correctly or not. So if you look at this one, okay, it seems everything is okay. We have customer ID, and we have another customer identification. So in this case, there's a duplicate column. It is duplicated. The customer identification has the same information with the customer ID because we are merging. So the customer identification still exists. So we need to eliminate it. We need to remove it because we do not need one of them. We can just have one of them, and let's remove this one because they are the same column. So in this case, we can do the same like the merging, and then we again do the left on, then the right on based on the customer ID and the customer identification, and then drop. Drop means we want to remove. We want to delete the column customer identification because it is duplicated with the customer ID. So after we remove this customer identification, let's again check the data. So we have the row number, customer ID, credit score, geography, and so on. And okay, there is no customer identification anymore. So the customer identification has been removed here. So we can start from this one. So this is the full data after you do the merging. So means number 4, we finish number 4, and then we can go to the next section. We need to solve the number 5 and number 6. Okay. For the next, we need to show the data description. Yeah. So I'm going to use one package to show the data description. I'm not sure whether it works or not. So before it doesn't work properly. So you need to install one package, and the package name is pandas profiling. In Python, we need to define this one, the sharp. When we use the sharp means we want to make a comment. This is the way to install a new package. So when you define like this text with the sharp, it is just an explanation. It is just a description. So Python will not execute this text. Python will just execute this text and this one, the compute, the exclamatory sign. It is used to install any additional package that is necessary for your analysis. pip, yeah, this is the standard command from Python if you want to install any package. To command install and then call the library name. So in this case, I'm using the pandas profiling library, and I want to install it in this computer. So it will take some time to install this, and I'm going to use this pandas profiling, and I will make it short, just pp, because if I use the pandas profiling, it is too long. So I make it short pp, and then I would like to divide the data in the profile report in the pp. That's it. So if you finish with this profiling, then you will see a kind of table to show you about the data profile. For example, here, yeah, it shows the number of variables. So do you know what is variables? It is the number of columns, the number of observations. It is the number of rows. How many missing values? 0. How many missing cells in the percent? How many duplicate rows? 0. How many duplicate rows? 0%. And this is only the memory size. So we have numerical attributes 7, and we have categorical attributes 7. So this is the overview. And you can see alerts. Yeah, they show you the surname has a high cardinality. High cardinality means there are so many different data. So if the data they are different, so it will be difficult to analyze. So maybe sometimes it is not that necessary. You know, many people have different names, so the surname is also different. Number of products is highly correlated with accident. So they can give you some kind of basic information. So this pandas profiling report is very powerful tool. You can check all those details. This is just the basic analysis in the report. And then you can see the variables, what variables you want to see. Let's say I want to see the geography. Okay, so we can see the France. There are for 5,000 data from France. There are 2,500 data from Germany. There are 2,477 from Spain. And yeah, we have three different data and so on. So we can use this one to indicate our, to answer the problems. So what is the 5-number summary of credit score? And yeah, you can select this column, credit score, and then you can check. This one shows you the 5-number summary. Do you still remember what is 5-number summary? Yeah. It is the minimum, Q1, median, Q3, and maximum. Okay. So we need to define for every of this item this on the values that you get in this provided report. What is the 5-number summary of tenure? Yeah, you can select the tenure. Okay. And what is the 5-number summary of balance? So this is the 5-number summary that you can get. So what is the exploratory data analysis for the categorical attributes? What is the highest number of customer country? If you look at this customer country, it is from the geography. Okay, France is the highest. Describe the ratio of the gender. So you can go to the gender. Okay, we have male is 5,457. So yeah, you can have the overview of the. Okay, yeah, if you click the toggle details, then you will have more characteristics like the frequency and then the percentage. Like this one, this is male. Okay, male is the blue one. We have male 5,457, and then the percentage is for 54.6%. And then the female is 4,543 with 45.4%. So when you have, later, if I give you another assignment, you need to write down all those numbers. So you can check your assignment in your assignment section. I already give you the assignment score. And yeah, I would like to know whether you understand the basic statistics of the data or not. So if it is the numerical data, then you can show the 5-number summary. If it is the categorical data, then you can also show the statistics with the proportion for each of the categorical values. So if you don't show this one in your assignment, then Yeah, I deduct the point. I give some minus on your assignment. Okay, so those things are the answer for the problem number 5 and number 6. I can also show you another kind of package to show the data description. This is another tools, another package, we call it SwiftPiece. It is a visualization tool. In this case, I'm going to install it in this computer. And I would like to import it. And after I import it, I will to make the report. So the report will be using the report will be using the data that I have before, and then it will be saved in the variable report. And I'm going to show it into the HTML file, and this will be the result. So basically, yeah, the visualization is similar with Orange. So you can see that it is the row number, it is the customer ID, this is the credit score. Okay. So this is the distribution of the credit score. And then this is based on the geography. So how many person from France, how many person from Germany, how many person from Spain. And then the tenure, this is the distribution, and so on. Okay. So they provide all those visualization in this very brief report with the Python. So the next problem is problem number 7. So in the problem number 7, we want to check the distribution of the exit customer. So the exit customer means it is from the column exit. So the column exit is exited. And I want to know how many customers did exit from France. So it means I need to make not exit and then exit. And then I need to know for every of the countries. We know that the countries we have France, we have Germany, and we have Spain. So how to calculate this number of frequencies? So in the orange, you can use the distribution, and then you can see what account. But in Python, I just give you one examples here. We can use the group by function. So it means I know the exited is the problem that we need to solve, and I would like to see also based on the geography. So if it is the exited is 0, then I can see how many is from France, how many is from Germany, and how many is from Spain. If the exited is 1, and I also can check how many is from France, how many from Germany, and how many from Spain. And we use this syntax to get the result like this one. So it is based on the exited, the first column, and then the geography, which is on the second column. And then I would like to count based on the exited. So it means this one, 4,204 is from France, and this is 0. 1,695, this is from Germany, and this is Mexico, and so on. So this is the answer for problem 7. How many customers who exit were male? So we can have another way, the group by, and we have two columns. So we want to know the exited and we want to know the gender. And the column will be based on the exited. So I will just make the exited and gender, and the column will be based on the exit. So this is the way to make the Python. So we know that the number of male who exit are 898. So from this one. Do you think the exit customers join many products from the bank? Assume that the word many means more than one product. So you also do this one with orange. The idea is the same. We can use the group by. We use the exited. And we use the number of products. And we want to count based on the exited count. So this is the number that is based on the exited count. So the exited equals to 0, the number of products is 1, 2, and 3, and then you can see the distribution. If it is exited equals to 1, then you can see 1, 2, 3, and 4. So how about the number of products which is more than 1? The number of product is 1 equals to 1,400. And the accumulation of this one, 2, 3, and 4, we have maybe 568. 568 plus 60. So the total is 628. Then, if the product number more than 1, the total is 628. But when the number of product is 1, the total is 1,409. And it means number of product of 1 is the highest, so the answer is no. So you need to give this kind of answer. If you don't give this kind of answer in your assignment, I will not give any point. I will deduct the point. So how many exit customers who have credit card? So the idea is still the same. We can use the group by. Group by exit has card and exited, and we want to check how many of them. So in orange, I think it's very easy. You can just click, okay, the exited equals to 1, and then you can check the distribution. In Python, yeah, we have different way to solve the problem. So here we have the exited members who have credit card. There are 1,424. And in number 8, I think the problem is more challenging. Here we want to see the features, and we do more things in these features. The first is we want to create a new column category, and then this new column category will be split. If the age is less than 30, then it is young. If it is between 30 and 60, then it is adult. If higher than 60, it means senior. So, yeah, you can use the distribution and you can show the ratio of the young and adult and senior. I give you one example to use Python to get the cutting point. So I'm making a new column, which is category, and then we are making the age, data age. It means I would like to cut this data. This is a numerical data. I'm using the cut function, and the cutting point is 0, 30, 60, and 100. Because the condition is if the edge is below than 30. So we need to define the minimum of the edge. What's the minimum of the edge? There will be no minus, okay, for the edge. So I just set up 0. So the 0 until 30, it will be indicated as young. And then the next is 30 until 60, it will be indicated as adult. And 60 until 100, it will be indicated as senior. So when we do the cutting like this one, so I'm going to make the labels. So young, it means from 0 until 30. Adults is from 30 until 60. And senior is from 60 until 100. Why 100? It is just a value that I think that maybe in this data set, the highest is 100. Of course, you can check. You can look at the age distribution. What is the maximum? The maximum is 92. Okay, then yeah, I can use 100 as the maximum value for the cutting of the data. Using the Wheeler distribution, show the ratio of young, adult, and senior. Okay, I have this one, and then yeah, I have the category adult, but how can I see the distribution? Yeah, you can use the example that I gave you, this one. For example, I'm using the sweet fish. Then let me use the sweet fish animal. So when I use this sweet fish, I can have a new category. This is the new category data, and you can see the distribution. Adult has a big distribution, like 76%, and then young 20%, and then senior we have 5%. Now the next problem is using discretize with equal frequency discretization. Hiding in the orange, yeah, you can easily make the discretize. There's a function, there's a widget discretize, and then you can change whether you want to use the equal frequency or equal width. And now the number intervals has been determined, which is 3. So we need to check whether the result will be the same with the problem A or not. So we have the QC, let's say. We have the function QCut. The QCut is the quartile cut. And the QCut is to select the best quartile. In this case, because we are going to split with the frequency, so I can just use the Q equal to 3. So this X will be used for the cutting, and then Q equals to 3 because we have the interval equals to 3, and let's use the precision equals to 0. So it means, yeah, the number will be just 0.0. When you do this one, and I know the cutting point is in between 17 until 34, 34 until 41, and 41 until 92. So 92 is the maximum age. So if there's question like this one, is the result the same as problem 8A? If it is different, explain the difference. So I guess in my case, I need to make let's make a new column. Let's say I make the QC. Okay. So the data in the column QC, it will be based on the variable QC that just generated with this function. Okay, and then let me use again this analysis. Let me just show the report again. And then if I look at the distribution, the category distribution shows that adult is the dominant. Adult and then young and senior. Senior is the least. But if we use this QCAT, then the distribution is somehow similar. So they have the quartile cut is on this quartile. So the result is different with the problem A. When we use the 30, 60, and 100, the distribution is different with the QCAT. Do normalization on the attribute estimated salary. And we need to show the distribution in the bin width 0.2. I think in the orange is not that difficult. You can just show the distribution and then drag and drop the 0.2. But in the Python, we need to use one function which is min max scalar. This is the function to make the normalization with the min max normalization. If you still remember min max normalization. We use the min max scalar and then we change this estimated salary with this function fit transform. So the original value, which is estimated salary, is 100,000 something, 112,000 something, like this one. Now we can see if we use this one, then the estimated salary will be in between 0 and 1. So it is already normalized. And I would like to give you one code. It is to check the distribution with the bin width 0.2. The bin width 0.2 means I want to plot with the histogram from the data estimated salary and the bins. The bins, we know the bins in the discretization is based on the 0.2. It is from the minimum of this data until the maximum of the data. And the step is 0.2. So we can see it is the data based on every 0.2, 0 until 0.2, from 0.2 until 0.4, from 0.4 until 0.6, and so on. And the last one is the sampling. Since there are limitations on the computer spec, we need to downsize the data from 1000 to 5000. What is the best method? So here, I just use the very simple code to make the sampling. Okay. This is in the Python code. We need to group by with exited. Do you know why? This is because we want to use the stratified sampling. In the stratified sampling, we want to make the distribution of the class equal. So it means when we have 10,000 data, let's say the 0 and 1, the distribution is now 40% for the class 0 and 60% for the class 1. Then if we reduce it into 5,000, the distribution should be the same. So here still 40%, and here should be still the same 60%. So we use the stratified sampling for that one. Okay. I guess all the answers on your assignment is correct. But if you do not do with the data sampling in orange, I will deduct some point. In the Python, we can use this command. We can group by with the accident, and then we have the function to do the sampling. Fraction 0.5 means we cut 50% from the total data. So if you see this one, then we have 5,000 rows among 10,000 from the original data. Okay. So this is the example of Python solution for your assignment. Hopefully, yeah, it is useful for you. And for next week,